Hello, welcome to the topic of Python Matplotlib. I'm going to give you an overview of how to use Python plotting library called Matplotlib to do simple data plotting. So first of all, I assume you have already installed Matplotlib, which is a package of the Python. If you have not, you can use this Anaconda Python I suggest on our website. Over there, you will have numpy, scipy, and matplotlib already. So to start a program that has matplotlib capability, first of all, you have to import the matplotlib pyplot module. And also in the example below, I'm going to use numpy to import to create the array data so that you can give that data to matplotlib for plotting. So the first thing you need to do in order to perform plotting using matplotlib is to create a figure, that is a drawing area. So in the example here, I call the figure method that takes no input. However, if you want to give your figure a name, you can use number, string, etc. as the input. And you can try it to see what will happen. After the figure is created, you can call different matplotlib methods to perform the plotting. And there are a few choices that typically used, for example, line graph, bar chart, histograms, pie chart, etc. I'm going to demonstrate the most basic one, that is to draw a line chart. In the example here, I'm plotting an array of 5 numbers, and then I provide this array as a numpy array, and I give that as argument to the plot function. To make sure that I can understand the plot properly, I will provide a label for the x-axis. Here I use the example of seconds, that is our x label. You can choose the output of a plot in an interactive window or save to a file. If you want to show in a window, you call the show method. And if you want to save the plot directly into a file, which is in the example here to a PNG image file, you call savefig method. Here I use show method to display the plot interactively. You can create multiple plots together using the subplots command. In the example here, I'm creating a 2x1 grid of subplots. That is 2 plots, 2 rows, and 1 column. That is 1 at the top, 1 at the bottom. And then I'm drawing a line chart using 5 numbers. And then I'm plotting the second subplot. This is the last number, 2 is 4. I'm plotting 20 random numbers in the range between 10 and 15. And when I call show method, you are going to show both of the plots. You can customize the label, tick marks, and grid, etc. In this example, I'm plotting 20 random numbers between the range of 10 and 15. And I create 20 tick marks for the x-axis from 1 to 20. And I'm set the y-axis label as random. And also, I want to overlay a grid structure on top of my line chart to make it easier to see the scale. And when I do call show method, then this is the result. So you can see that on the x-axis we have 20 tick marks. Over the y we have a label called random, and then the grid is very clear. That helps you to see the exact value of the function value. So you can create multiple graphs in the same chart. In the example here, I have input x to the plot method, which ranges from -2 pi to 2 pi. Then the input x is given to sine and cosine functions. So I'm drawing 2 plots. One is sine, the other is cosine. And I also label them as graph 1 and graph 2. And I'm going to add the legend, which is going to show you which one is graph 1, which one is graph 2. Then I display. So you can see that I have 2 graphs. One is for sine, the other is for cosine, and range of between -2 pi to 2 pi. This is how you create two graphs in a single chart. Besides line charts, you can do bar chart. Bar chart is a common method for you to see a sequence of numbers. In the example here, I have an X array 1, 2, 3, 4, 5, and each of the X value will correspond to a Y value. They are a mix of integer and floating points numbers. And I want to draw a bar chart, so I want to make it clear 5 different bars. So I put a label or X tick marks if you want, from B1 to B5. I'm going to draw the bar chart by calling the method bar, and you see this is the result. Notice I have a rotation minus 60 when I create the X ticks, and you can see here the label from B1 to B5 are rotated by minus 60 degrees. This is how it is done. Now, pie chart is another common method. In this example, I'm creating 7 random numbers ranged between 1 and 10. And each of the number, I have a label from B1 to B7. And I'm going to draw a pie chart by simply calling the method pie. And I'm adding a title, a pie chart example. And this is the result you have. Notice that the label is a list L, and I give the L list to the method pie, indicating this is for label. You can draw a histogram. Histogram is a common method to show a distribution. Basically, you have a sequence of numbers, and for each number, you show the count or frequency corresponding to that particular value. So in the example here, I create 1,000 random numbers range between 0 and 0.1. And then I want to divide the range between 0 and 0.1 into 100 bins. And for each bin, I'm going to show the number of values fall into that range. And this is the definition of histogram. And this is the result. You can do scatter plots and box plots. So scatter plots create a two-dimensional space. The x coordinate is the x value, and the y coordinate is the y value. So here I'm creating 50 random numbers range between 1 and 100. Then for every x and y tuple, we have a point on this two-dimensional space. So the scatter plot is to plot the 50 points, and the values of the points, that is the coordinates of points, are created by my random function. The box plot is a common method used in statistics to show a range of value. So here I'm creating 50 random numbers uniformly distributed between 1 and 100. And I simply give the numpy array to the method box plot. So here what you show is you see the minimum value, the maximum value. Also, the box plot start from the end of first quartile to the end of third quartile, and you also show the mean value in the middle. So in this example, the mean value is about 60. Now my last example for Matplotlib is to show you how do you display an image. So images are something commonly used in medical application. In this example, I am loading an image data using the numpy from file method, and I have a image called head mr volume.row. And after read this data, I reshape into a sequence of images. It is a 3-dimensional cube. The dimensions are 42 by 62 by 48. And then the method used in Matplotlib package to show image is called ImShow. So I'm slicing the data, which is a 3D cube, remember? I only show one single 2-dimensional slice that has I index equals to 20. and I show in the first image. This invert y-axis is essential to flip the image. The second plot, I'm slice the cube at y equal to 20 and show that slice from the 3D volume in the output. And finally, I slice the cube from z equal to 20 and I displayed it. Okay, so this is a quick overview of how do you use Matplotlib. You can see that it's very easy to plot data in a simple way. However, a lot of times that's all you need. So it's very powerful for you to generate quick view of your data.